Mathematics brings to the table this process, yes. The first is perception of reality. We see, we hear, we smell, we taste, we feel. That's five senses, and we intuit, use our imagination, okay? And after we have done this to the real world, to reality, the mind thinks using words according to the native language. So if you speak English, your mind, you will be speaking in terms of English in your mind. If you speak Spanish, you'll be speaking in terms of Spanish. If you speak French, you'll be thinking in terms of French words that will be in your mind. And Japan, China, German, all different languages according to the language, even the tribal people and so forth. And generally, we think in two general forms, qualitatively and quantitatively. Yes, qualitatively, we may look at the color of what we are perceiving, the texture, the aesthetics, and so forth. But quantitatively also happens simultaneously. We may look at the height, the width. We may try to estimate how many are there, how much it costs, the temperature. All this will be, or maybe going through our minds. So the qualitative and the quantitative approach to perceiving our reality will be occurring simultaneously, okay? And this will be interpreted using words according to our native language. Then we may imagine the abstract now. So it's from the reality, perception of the reality, that's objectivity, and imagine of the abstract, that's subjectivity, because we need to socialize and we need to communicate, and that requires a language, either spoken or written. Spoken language, we'll be making sounds, and written language, we have to create symbols, okay? And for both qualitative reasoning, we have to write using words, okay? And quantitative reasoning now, we'll be writing now, and the words now will be translated to mathematical symbols. So that's what basically will happen, because we first will be thinking using words, and to facilitate the documentation of the quantitative reasoning, to make it more efficient, we have to convert those words to symbols, mathematical symbols. So that's why in the math text and so forth, you'll be seeing a lot of symbols. Each symbols represent a word, probably even a sentence or a paragraph. One symbol could mean a whole paragraph. Imagine that. So that's why mathematics now can be considered as that it first starts when we objectively perceive the real world with the five senses, okay? Then in order to communicate the subjective abstraction of the mental image that was formed in the visual cortex and other areas of the brain, we design diagrams and graphs. We also convert words to symbols. That happens a lot. In that way, we facilitate the documentation, thus the written communication, right, of ideas involving numerical analysis. Okay, so for example, you may perceive in the real world a car that's moving. Okay, so that's what you may see. And you may hear the sound also, or smell the exhaust. And that's what you perceive in a car is moving. And you may there mentally thinking in your thoughts and probably even writing down, but using words. I saw a car moved a distance of 200 meters in 10 seconds from left to right. So you are quantitatively, thinking or even writing what you perceived, all right? And continues, therefore, the velocity of the car must be 200 meters in 10 seconds in the positive direction. So from the perception of the real to quantitative mental thoughts, using words, thinking, and even writing it down. And quantitatively writing, reasoning, using graphs and symbols. So quantitative written reasoning using graphs and symbols. So from words to graphs and symbols. So here you have a graph communicating what is actually happening or what actually occurred. Time, you start counting from the time you began watching the car. 2 seconds, 4 seconds, 6 seconds, 10 seconds. And whilst the clock is ticking, the distance from the reference point is increasing. The car is moving from where you began watching it. 50 meters, 100 meters, 150 meters, 200 meters. So in 10 seconds, the car has moved from 0 to 200 meters from the reference point. And from that now, from that information, instead of distance, right? So you see words now turn into symbols. One letter D stands, D for distance, is equal to, all right, the symbol for equal sign, positive 200. This is the symbol for 200 meters. T for time is equal to 10 seconds. And the velocity, V for velocity, is equal to 200 divided by 10 to give you 20 meters per second. Okay, so therefore you can actually see the process of a real perception, a real phenomenon being perceived to words, to symbols. And this, ladies and gentlemen, is very frequent in mathematics. So that's why mathematics can be considered a language, because you are translating from the real, you are translating from words to symbols, from words to graphs to symbols. It's like you're translating from one language to the next. Yes? To facilitate quantitative reasoning.